you go. Hello, everybody. Welcome to our webinar for today, our Dig In. We're happy to have you. We're gonna give folks a little bit of time to get joined in, and we'll get started shortly. All right, seems like folks are arriving, but we're gonna go ahead and get started. Hello, everyone. Welcome to our Dig In on hydrology, construction, and testing for the Florence Copper In-Situ Copper Recovery. My name is Mario Munoz, and I am the co-chair of Education Outreach for the Women in Mining Arizona chapter. First, we'd like to welcome you, right? Before getting started, we also want to give a brief introduction to our organization and why we are hosting these talks. Next slide, please. The Women in Mining Arizona chapter, or WIM Arizona, is a nonprofit organization with several objectives, one of which is education of our members and the public on technical, economic, regulatory, and other mining-related topics. To meet this commitment, we are hosting these monthly dig-in events. Next slide, please. We also want to give a brief thank you to our sponsors. The WIM Arizona 2020 Platinum sponsor is Freeport-McMoRan, and the sponsors for today's talk is Montgomery Associates as a payload sponsor and Stantec as our prospector sponsor. So thank you very much for making this event like this possible and our other outreach efforts. Now I'm going to turn it over to Tim Bailey with Montgomery Associates for a few words from our sponsor.
Hi everyone, I'm Tim Bailey. I'm a hydrogeologist with Montgomery Associates. Megan and Lauren asked me to come in today and just introduce our firm to the group. So first, we're really happy to be sponsoring this talk and really proud of the work that Lauren is doing at Florence and that Megan's doing here with Women in Mining. Most of you probably have some familiarity with Montgomery. We've been around Arizona since 1984 and focus in the mining sector on EIS and APP permitting, mine dewatering, in-situ leach mining, mine water supply, tailings and environmental work, and groundwater modeling. Right, you can see a map of our offices and projects. We have offices throughout the West in Arizona, Salt Lake City, Elko, and 4 offices actually in California, and then also offices in Salta, Argentina, and Santiago, Chile. So really happy to be working in the mining sector and looking forward to Lauren's talk today. Thanks.
Awesome, thank you so much for that, Tim. Now I'll be introducing our speakers for today. First up, we have Lauren Candreva. She is a senior hydrogeologist and the Phoenix operations manager for Montgomery Associates. Lauren received her bachelor's in geology from Northern Arizona University in 2004 and has been working in water resources consulting in the Southwest US since then. She's a professional geologist registered in Arizona, California, and Oregon. In 2017 and 2018, she supported the Florence Copper Production Test Facility by partnering with Florence Copper Hydrogeologists to oversee and manage the drilling, construction, hydraulic testing, and mechanical integrity testing of the wellfield and associated compliance and monitoring wells. She has supported the Florence Copper project in varying capacities since 2010. In her spare time, Lauren is busy raising 2 girls and with her husband, Mike. Now, Stacy, raised in Mesa, Arizona, Stacy Gramazio graduated from the University of Arizona with a BA in Media Arts. After spending a decade in Los Angeles working in television production, she and her family moved to her home state of Arizona in the new area of Santan Valley over 13 years ago. Upon her return, Stacy taught for the Florence Unified School District and Central Arizona College. She joined the Florence Copper team in 2012 and has led the communications and public affairs staff through the permitting and public review process. She is also the chairman of the Greater Florence Chamber of Commerce and serves on the Arizona Forward Central Regional Council and the Board of Directors for Central Arizona College Foundation. In 2015 and 2016, she was recognized by Central Arizona College for exemplary leadership in Pinal County. In her spare time, Stacy is busy raising 2 active boys with her husband, Chris. So thank you and welcome thank you for being here. And we're gonna turn it over to you. But before we do, as you get the slides ready, I just wanted to go ahead and let you all know that if you have any questions throughout the presentation, make sure to enter them in the chat or in the Q&A feature at the bottom of your screen. You should be seeing the 2 options, and we'll have some time throughout the presentation to answer those questions. Now over to you.
Thank you, Mario. Can everybody see my screen? Yeah, okay. So I'll go ahead and get started. Thank you for inviting me to be here today, and excited to see all the participants. Donna, can you give me a thumbs up if you can hear me okay? Make sure before I get started. Okay. So today I'm going to talk a little bit about the Florence Copper production test facility that I was involved with supporting in 2017 and 2018. Just an overview of what we're going to talk about today is up on your screen right now. I'm going to focus specifically on the production test facility because that's what I was involved in. And then at the end, Stacy's going to jump in and give us an update on where the project is at now and where they're headed. So I'll go ahead and get started. So in-situ copper recovery. ISCR uses well-to-well leaching to recover copper from the subsurface. Unlike traditional mining methods where the ore has to be removed from the ground, it's all done in situ. ISCR has been widely used for decades to extract copper that was not commercially recoverable subsequent to conventional mining, like at the edges of pits and within leach pads. Greenfield ISCR is relatively new for copper, and Florence Copper is actually the first permitted greenfield ISCR project in the world when it was originally permitted back in the 90s. So this presentation is going to focus on the key hydrogeologic and environmental parameters and the considerations for the greenfield or unaltered ISCR projects. So what makes Florence Copper site ideal for in-situ copper recovery? The Florence deposit has a highly fractured ore body. The ore is hosted primarily on the fractures. The ore body at Florence is entirely saturated, so the groundwater elevation is above the targeted ore body. The site has a low background hydraulic gradient, which means it makes it a little bit easier to develop hydraulic control and then maintain it, which is required for in-situ copper recovery. It has sufficient hydraulic conductivity for well-to-well leaching, so the solution can move from well to well in a time frame that's meaningful for recovering the copper. And then the Florence site has a long history of study and characterization, including more than 20 years of water quality data. The site was explored and drilled on 250-foot centers, so there's a lot of information on the ore body and the fracturing within the ore body. And so those are what makes Florence Copper unique and ideal. In addition, the host rock at Florence Copper is made up of relatively clean rock, so non-reactive or lower reactivity than some other rocks that host oxide copper deposits. For those of you that are not familiar with Florence, Arizona, it's located a little over an hour southeast of downtown Phoenix. This is a map of the site. So the dashed black line shows the property boundary that's owned by Florence Copper. Within that boundary, the green line shows their state mineral lease boundary that's within their property. The pink line shows the mineral reserve outline that's targeted for in-situ copper recovery. And it's very hard to see on this background, but there is a small yellow dot within that green box that shows the location of the PTF wellfield. So the project history. Conoco started developing the site back in the 1970s. they sunk 2 shafts and evaluated doing underground mining, pit mining, and then began looking at the option of ISCR. But that project died in the late 1970s. In the 90s, Magma restarted the project and started really looking at the ISCR option. Magma and BHP then combined, and the site was fully permitted for in-situ copper recovery in 1996. In the late 90s, after BHP conducted an in-situ copper recovery test, that project died. And then in 2009, the site was purchased by Hunter Dickinson, who established Curious Resources to manage their Arizona assets. And then Taseko acquired the project in 2014 and has been managing the project since that time. So in order to do ISCR, you have to process the solution that comes out of the well field using SXEW. I don't know why that's so hard to say, but this is actually the picture of Florence's SXEW plant that was constructed for the PTF facility. It's a full-blown SXEW plant, but in a mini version, and this will be expanded as they go into commercial operations in the future. So a little bit about the geology of the Florence deposit. The Florence deposit is within the Ray lineament, which also includes the Ray mine and the Sakatone mine. And the Sakatone mine has actually also been evaluated for in-situ copper recovery. Some of the key components of the geologic history of Florence Copper that make it unique for this type of mining. During the late Precambrian, the Ray lineament was formed. And then in the mid-tertiary, hydrothermal mineralization associated with the intrusion formed the copper deposits that are currently being mined. And then post-basement range, basin fill sediments buried the deposit. The thickness of the deposit at the Florence site ranges from about 300 feet to over 900 feet. So specifically at the PTF, the rock that hosts the mineralization that was targeted for in-situ recovery is an intrusive rock. It's primarily quartz monzonite and some granodiorite porphyry. And also within the ore body, there are intruded diabase dikes throughout the site. In the area where the PTF has been developed, there are 3 major named fault zones. The Sidewinder, the Rattlesnake, and the Thrasher faults. And there is oxide and sulfide mineralization at the site. The ISCR is obviously targeting the oxide zone. So this is actually a cross-section of the site. The PTF is, if you can see my cursor, is actually located in this high region on the north end of this cross section, and then it shows where the BHP ISCR well field was installed. You can see the faults that were mentioned. The orange is the quartz monzonite, and the purple is the granodiorite porphyry. You can see the other rocks intruded throughout the deposit. So this includes most of the site. So commercial mining will extend out in this region, but the PTF is all the way out here, but the PTF is installed here on this bedrock high. So the structure and mineralogy of the site, pre and post mineralization faulting at the site has created a highly fractured bedrock ore body that's required for the in-situ copper recovery. The statistical analysis conducted on drill core at the site shows an average of 11 to 15 open fractures per foot in the oxide, and that's important because that's one of the things that increases the hydraulic conductivity, allows the water and solution during the mining process to flow through the rock and recover that copper. So for the hydrogeologists, these are the units that were modeled to support the permitting at the site. There's upper basin fill unit, middle fine grain unit that acts as a confining unit regionally in the area, the lower basin fill unit, and then the bedrock oxide. The bedrock oxide is where the mining is occurring. And there are some hydraulic parameters listed on here that show the differences in transmissivity and flow through the different units that are present at the site. So groundwater permitting. Florence Copper has had to permit the site in order to conduct in-situ copper recovery. They first were fully permitted for the ISCR in 1996 by BHP. Some work was conducted under that permit. They conducted their in-situ copper recovery test at the site. It was shortly after that that the project died, but the permits were maintained even as the property was transferred to a developer. Currently, Florence Copper holds a temporary aquifer protection permit, APP, for the operation of the PTF and an underground injection control permit for the PTF. The commercial phase of permitting is ongoing now. That includes a significant amendment to the 1996 permit for commercial operations to include the planned operations now, which are quite a bit different than what was planned in 1996. And then an update to the underground injection control permit to include commercial operations outside of just the PTF area. In order to obtain the permits, a groundwater model had to be developed for the site to demonstrate how the solution would move through the ore body. So the groundwater model was originally developed by Brown and Caldwell and then was updated by Haley and Aldrich. It is an 8-layer model to model the basin fill and the oxide units. And it was used to evaluate the transport of the in-situ copper recovery fluids. The model was based on the Pinal and Phoenix AMA model with a refined grid in the project area. And the components of the permit that they're required to keep the solutions within were determined using this model. So the PMA, the pollution management area, and the area of review for the UIC permit. So now a little bit about the PTF design. This is actually a picture of the PTF well field up on the screen now. And this is a map that shows the layout of the PTF well field. So there are 4 injection wells, 9 recovery wells, there are 8 observation wells, and then there are 4 multi-level sampling wells. It's basically a 5-spot pattern that during commercial production will be repeated within the mine blocks for the PTF because it was just a single 5-spot. There's a ring of recovery wells around the injection wells. So here are just some of the typical designs. This is the injection well that shows they had 3 screen intervals. For the injection well, there was a overburden casing that was drilled and set prior to installing the well. So we drilled the overburden casing. It was grouted from the bottom up. The rig was moved off, and mechanical integrity testing was conducted on that overburden casing before drilling the lower portion of the borehole and constructing the well. This is the recovery well design, and this includes resistivity probes that were installed in the annulus of the well to track solutions through the mining process, as well as an annular pressure transducer that was strapped to the outside of the well when it was installed to monitor water levels in the aquifer and be able to determine if there was a difference between water levels within the well and water levels in the formation due to well efficiency. And here is the typical observation well design. So the observation wells are installed around the perimeter of the well field, and their primary purpose is to demonstrate hydraulic control. So water levels. Florence Copper is also obligated to conduct or collect water samples and measure electrical conductivity from the water in these wells as part of their compliance program. And these wells also have an array of resistivity sensors that were installed in the annulus to identify movement of solutions. And they're on the outer wells because they communicate with each other across the well field to collect the data. So it's not that the solution would be at observation wells, but Data would be communicated across the well field from observation well to observation well. And this is a typical design for their multi-level sampling well. These were installed halfway between the injection wells and the center recovery well to track the movement of solution during the mining process. And so there are 5 screened intervals, and these wells were equipped with a West Bay sampling system to get discrete samples from each of these 5 screened intervals. So in the ISCR process, the acid is injected into the center well, and then the recovery wells adjacent to it pull it through the ore body and into the wells, and then it's recirculated to enrich that solution. And then when it gets to the point where it's enriched to the level that it needs to be, it's sent to the SXEW plant to be plated out. There are perimeter wells, and then this diagram also shows an observation well at the outside of the well block that are used to look at hydraulic control and groundwater elevations adjacent to the well field. So as part of the PTF, Florence Copper was required to demonstrate some operational things before they started injection. These were their pre-operational requirements. So they had to conduct ambient groundwater quality monitoring to establish alert levels for their POC wells and for their EPA wells under both the APP and the UIC. They had to conduct ambient bulk electrical conductivity monitoring at the compliance probes in the wells at the site. I'll talk more about that in a little bit. They had to demonstrate mechanical integrity of the wells. That included the integrity evaluation that was done on the overburden casings in the recovery and injection wells prior to construction of the actual well inside of them, and then cement bond logging and standard annular pressure tests on all of the wells. And in addition to pre-operationally, that's something that they have to demonstrate continuously through the process. They also had to conduct a tracer test where a tracer was actually injected into the injection wells and recovered at the center recovery well. Formation testing, so they had to conduct pumping tests at select wells within the well field. And prior to operating using mining solutions, they had to operate the well field using water to demonstrate they could establish and maintain hydraulic control at the well field. They also had to abandon any existing wells and core holes that were within their area of review to ensure they weren't a conduit to mining solution. And then they were also required to do freshwater testing of the SXEW plant before they began operation. So Florence completed all of that, and this is actually a groundwater elevation map that was generated from the hydraulic control test prior to mining. And so they're required to overpump. These are all conditions in their permit. There's a certain percentage overpumping that has to be done compared to what's injected to ensure they maintain an inward hydraulic gradient toward the well field. And they're paired observation recovery wells. So each of the observation wells is paired with one or more recovery well, and there is a required difference between those 2 wells that's a compliance point to maintain for demonstrating hydraulic control. Groundwater monitoring that has to be conducted in support of the permit. There are 31 site-wide monitoring wells for the site-wide permit. 16 wells are monitored for the PTF. Over 20 years of background water quality data has been collected under the 1996 permit and now under the current permit. Water quality sampling is done from the monitoring well network quarterly and has been over the last 20 years for the wells that have existed that long. In addition to that, Florence Copper takes daily observation well conductivity measurements, which is also a compliance point in their permit, to determine if those wells exceed the conductivity levels established in their permit. They have to do continuous monitoring of paired well water levels. This is done through their PLC system and done automatically and set up with the alarms for their compliance points. Monthly groundwater contour mapping to demonstrate to the agencies that hydraulic control has been maintained. And then they also have a compliance point for resistivity monitoring across the lower basin fill unit and the oxide contact. So resistivity monitoring, hydrogeophysics supports the resistivity monitoring that's done at the site. There are compliance sensors that are across the LBFU and oxide contact to watch for movement of solutions outside vertically above the mining area. And then they also have operational monitoring sensors through the ore body. So the observation wells and the recovery wells are all equipped with sensors that can collect data about fluid movement through the ore body. And this is a demonstration of watching of the multi-level sampling wells. So Florence Copper began operation of the PTF in December of 2018. So the first block on the upper left is prior to injecting any solutions. And then these are about every 2 months or so, show increases in conductivity in the multi-level sampling wells that show the movement of solution through between the injection wells and the center recovery well. So this has been useful data for them to look at how the wells are communicating with each other. So now I'm going to turn it over to Stacy Gramazio, who can give us an outlook and an update on where the project is going next.
Sure. Can you hear me okay? Thank you, Lauren. That was a great presentation, a great overview of the project. And I see there's a lot of questions coming in. So, and a lot of them are technical questions. So I'll look to you to answer some of those. But it's been great to work with Lauren. Thank you, everybody, for joining this. And thank you to Mario for the great introduction. Just to give you a few project updates, I know many of you have followed this project for a long time. And unfortunately, the town of Florence initiated a lot of aggressive litigation against this project. Today, we did have an announcement that the Court of Appeals upheld a decision in our favor. So if you followed this, this was questioning Florence Copper's right to mine on our private property. So we unequivocally have the right to mine on our property. The appellate court rejected every argument made by the lawyers representing the town of Florence. They upheld our right to mine on the property, and the court also confirmed the awarding of $1.7 million to Florence Copper. So we're grateful to get past that. We're hopeful for a good path forward here in Florence with the town of Florence specifically. Other updates, we do have our final aquifer protection permit that was issued by ADEQ December 8th of 2020. So we are operating the PTF under that permit. This was after a substantive review and a very successful public comment period. Our application for the other permit that we need, which is the federal permit, the underground injection control permit, that was submitted in August of 2019. It was deemed administratively complete in October of 2019, and that technical review is ongoing. We do require that final UIC to commence construction of commercial operations. We're really confident in the draft permit, and we're very confident that we'll receive a draft permit, in the near future. So once those final permits are in hand, and the TASECO Board of Directors does decide to move forward, we will begin construction for commercial operations. That will take approximately 15 to 18 months to construct that commercial plant, and operations will begin then. So we've had a long road with permitting and some litigation with the town of Florence. But we really feel that we're on a great path forward for this project, and we're looking forward to the next steps. I think Lauren and I are happy to answer any questions you may have.
Well, thank you very much for this presentation. We do have some questions. So let's start off with a fun one. We'll go with some technical here. Are your piezometers automated or manually recorded?
So the observation wells that are used to maintain hydraulic control that are on the outside of the well field are automatically recorded. They feed into the mine operation system and are recorded automatically.
Right. For the tracer, is it made out of a fluid dye or miniature physical object?
It was a fluid dye, so it was a fluorescent tracer that was used. The green one, I forget what it's called, but.
Keep away from the green stuff. So what is the typical depth limit for in-situ leaching, and could you potentially install in-situ leaching recovery wells in a pre-existing underground mine?
I don't know for in-situ copper in-situ leaching if we can really comment on a typical depth, just because Florence Copper is kind of the one of the first to do it. I think the limit would be, in the formation itself, and then just being able to lift solution to the surface. So it could definitely be done in a pre-existing underground mine, and I think there's quite a few projects that are kind of speculative at this point that are looking at opportunities to do that. But like we talked about, some of the parameters that are required for a successful in-situ copper mine are really going to be the limitation. The deeper you get, your fractures are going to have more pressure and not be as open, and so it would become more challenging and more expensive to pump.
Could you potentially utilize bioleaching in the in-situ leaching operation?
I believe you could. I don't know much about bioleaching, and if that would be in relation to recovering copper or for something else. I know in-situ bio components are used for, environmental applications quite a bit. So.
Okay. How about this one? What is the resistivity contrast between leachate solution and the ambient groundwater in the oxide zone?
So one of the slides I had up a little bit ago shows, let me see if I can go back. So, the background resistivity or conductivity is really what's measured, is very, very low. And so this shows conductivity up, over 40,000 for kind of the initial solution. So it's a huge differential between background and what's measured in the mining solutions. And I also asked Ian Ream to join this talk so he could answer some of these questions if I can't, because he's a lot more familiar with the actual operation of the site than I am. So if any of these questions are not sufficient, let me know and I'll make him jump in.
Great. Do you anticipate any potential increased groundwater use in Pinal County resulting from the 2019 DCP to affect the operations?
So Florence Copper has groundwater rights to extract the water they need, and in-situ copper recovery is actually a pretty low water use mine because the fluid is recirculated and recovered and reused to a large extent. And so I don't think they foresee any complications from the 2019 changes in the DCP. But Stacy, if you have more information on that, feel free to jump in.
Yeah, you are correct. We use about half of what housing would use on the same amount of land. We do wear out the water and recirculate that. I do not know for certain the answer to that question as far as what future growth may be in Pinal County and how it might affect it. But certainly I can take down any of these questions and get a more comprehensive answer. But at this point in time, I do not believe that we have concerns.
Okay. On that same vein, what is the source of the water that you have water rights for?
Groundwater.
Pumped on site?
Yes.
Great. Okay. Is there any estimation of acid loss during the operations? And if so, how much?
Okay, that's beyond my level of expertise. That's something that Stacy's going to have to maybe go back to the metallurgists and operators for and get back to you guys on.
Not a problem. Just to let everyone know who's watching in that we've got these comments recorded. We'll be working with the company and reaching back out when we have answers on some of these that we can't answer right now.
And
another,
Donna, if I could just clarify, there seems to be some questions here that are speculative about what could happen. The company only has plans to operate within our current public permits, and I just want to be clear about that.
Thank you, Stacy. Back to modeling. Why did you consider 8 layers for this model?
So that's based on extensive hydrologic testing that was done at the site back in the 90s to establish the parameters for the model. And it also correlates to the Pinal AMA model to a large degree. And so those layers were based on changes in the hydraulic parameters of the formations that were being modeled.
Back probably to Stacy for this one. How does the initial CapEx of an in-situ operation compare to that of a heap leach operation?
I'm sorry, could you repeat the question? I don't see it in the questions here.
Is there a difference between the capital expenditures of starting up in situ versus heap leach?
I don't know the answer to that, but certainly I would take that question and get it back to your members. That is beyond my area of expertise, but I can tell you that Florence Copper is a low-cost producer. So we cost about $1.12 per pound to produce copper, and we're confident that we will be in operation for a long time.
Yeah, and that's going to vary quite a bit, I think, based on the site, just the depth to the ore body and the nature of the ore body. There's just a lot of, I don't know if you could kind of say that generally, but.
Okay, on that idea of long-term mining, after the lifespan of the leaching operation, how much copper is left in the host rock?
That is another question that is going to need to go to the metallurgist or one of the Florence Copper. I'm a hydrogeologist, and so I am involved in the permitting and well drilling and construction. But as far as the actual mining, that's I think a talk for another day. There's a lot of information on it, and we'll have to get one of their technical experts to sign up for another lunch talk to cover all that information.
Not a problem. Let's go for the big fun trucks because everyone likes the big equipment. Question is, with this type of operation, is there any heavy equipment that's used, or is it all mechanical and chemical systems?
To maintain the site, there's basic equipment that's required, but for the most part, no. None of the big giant trucks. It's mostly done through pipelines and pumps.
No big fun yellow trucks. Okay. So that's the majority of the questions that we've been asked and gotten in through the question and answer in the chat. We'll work with the company to make sure they get a copy of all of these, and we can reach back out if we've got answers. Megan, do you want to take us ahead?
Oops. Everyone can see my screen. First, just want to say hi, I'm Megan, the Education Outreach Chair with Women in Mining. I want to say thank you, Lauren and Stacy, for presenting to us, and thank you to everyone who's attended. We appreciate everyone that attends and makes these events successful. We posted in the chat how to connect with us, and through LinkedIn, through Facebook. Let me advance the slide, and just a note of our upcoming dig-in talks. We have on April 20th, the shaft sinking at Resolution Copper with Clarissa Escamilla. And May 5th, we have virtual geology, inclusive field course development in the age of Corona. And June 16th, history of women mining in Arizona with Westland Resources. So please come to our future dig-in talks, and the Zoom links to register for those are in the chat. And I'll turn it over to Donna to talk about our event next week.
Great. So again, thank you to everyone who came out for today's event. We have another event next week, which will be a lot of fun. While we're still dealing with COVID, we have found a great software platform that we can attempt our best to network virtually like we would at a conference. So we welcome all of you to join this free event next Wednesday afternoon on March 31st and come out and interact with other people of the mining industry. We've got everything from large mining exploration, tables specifically to certain trades or positions in the mining industry, those looking for jobs and recruiters. And we just hope everyone can come out, and while we are still stuck at home right now, we can at least try to pretend that we're not. And that link is also in the chat that Megan put out. So go ahead and register.
Thank you everyone for attending. Thank you again for presenting, Lauren and Stacy.